Good morning, everyone, and welcome to the roadshow that is online. Make room for electrical design in your digital thread. So now I will hand over to Nils.
Thank you, Carolina, and welcome everybody. Thank you for taking your time to listen in this morning. My name is Niels Persson, and I'm the product manager in the Nordic region for our internally developed products. But today, I will also be your moderator for this event with the title Make Room for Electrical Design in Your Digital Thread. And with me to present on this topic, I have some of my esteemed colleagues, starting with Rebecca Roos, who is the sales director in the Nordic region. We got Mikko Hinkanen, he's a multi-magician, but excels in CAD and CIE, also working with our customer success team. We got Thomas Irla, business unit director for CIE, and Carl Fredrik Kastengren, business unit director for IoT. We have quite a long session for you today with a lot of shorter slots, starting with this welcome slot that we're in right now. I will continue to quickly give you a brief update on PDS Vision as a company and where we stand right now, and some of the market trends that have led up to this topic that we have for today. Rebecca Roos will continue on ECAD as a crucial part of the bill of material, and Mikko will deep dive a little bit on the topic with ECAD MCAD collaboration. Thomas will talk about CIE design validation and how you can use CIE as to validate your designs rather than having physical prototypes to do your testing towards. Then we will have our first question slot for the first three slots that we have. So it's 10 minutes open for your questions, and feel free to write them during the sessions in this question tab that Carolina mentioned earlier. In the second slot, Mikko Hinkanen will talk about material selection towards CIE. I will talk a little bit about product compliance as it relates also to the electronic design. Then we will finish off with Carl Fredrik, who has a topic of gather and learn, connect digital twin and digital thread. After that, we will have our second question slot, and then we will summarize the full webinar as a whole. So I will start a little bit short on the updates in regards to PDS Vision as a whole. And if we're going to size it with one word, it is that we have grown the last couple of years. This year, we also added Scons, an American company, to the list of acquisitions that we made during the last couple of years. And I will say that this is your typical PDS company. It has a strong service organization, support and training. The big differentiator is probably the marker within the Indian part of the map, where they have a big development unit as well. And together with Boundary, that joined us a couple of years back, Scons now also makes up a third of PDS Vision in the North American region. In the European region, we have strengthened Germany with former NET. UK, both Root and Wild had joined the UK team, and both Net and Root is also strong within the CAD and PLM space with their own training and support and internally developed applications. Wild, however, it's a full service provider for engineering simulation solutions and offering a multidisciplinary consultancies, mentoring, and also training in that regard. In the Nordic region, there are no new acquisitions, but we have a lot of new faces, some of which you might get introduced to today. And together as a bigger and stronger PDS Vision, we will continue to aim at being the preferred advisor for your digital transformation journey, the company to work for and with. And I would say one of the reasons for the success we've had is working close with our customers. That we understand you and your business is crucial for us, and the only way to do that is by communicating. So we're very glad to be able to get out on the road again and to meet with you guys. And this is the digital version on the ongoing roadshow that we are currently performing in a few locations. But we are really looking forward to invite you to more events like this one during the next year. So please reach out to us on the various topics that you are interested in and what you would like us to cover. One event that I know has been requested a lot and something that I look forward to myself is the PDS Forum, and it will re-emerge next year and it's currently in the planning. So we will make sure to let you know more about it once the time and place is final. So for the topic of today, we have not really taken the time to speak about electronic design earlier. And from a technical perspective, it's been handled somewhat separately from other product information. But as I think you will see today, there are some great tools to work with ECAD throughout the full product design process. And today, more than ever, it is of importance to make it a part of your digital thread. We see that your products are becoming more complex and they are including more electronics. And these components should, of course, also be reflected with all other product information. So it's time to step away from the outdated manual steps and isolated information, making all the relevant data part of the digital thread that runs through your company, where everyone has access to the information that they need and at the time when they need it, and always from the same source. And today we live in quite uncertain times, and the aftermath from the pandemic did not have a time to blow over before Russia decided to invade Ukraine. And first and foremost, this is, of course, a devastating humanitarian disaster that has emotionally affected all of us. But for many, this has also affected both private and professional relations with people and companies within this region. The Russian invasion has also led to an energy crisis unseen in modern time in Europe that will most likely have a continued impact on component shortages, disrupting supply and stops in production. At the same time, regulatory pressures are becoming more and harder, creating new complexities to product development. Under these conditions in this new world, I would say it's harder than ever to be a global manufacturing company. We strongly believe that this will require manufacturers to continue to push their digital transformation forward, to review how you are working today, and to define a more effective way of working tomorrow. And an example of a digital transformation action could be, how do we handle electronic design? Can we mitigate risk and make better strategic decisions early in the design phase by making it visible with all other product data? Can we utilize digital simulation tools as a complement or as a replacement of physical prototype testing, resulting in quicker and a cheaper process? Can we gain knowledge about our own products using IoT, or can this exciting technology help us also extend our digital thread? We hope that the following hours will gain you some insights on how you can manage electronic design, starting with Rebecca Roos.
Thank you, Nils. So we're going to stay on this topic of complexity and transformation a little bit longer, because all these factors that Nils just mentioned have in common that they put demands on companies to be in control of their product information and internal operations. Whether it's the energy crisis, regulatory pressure, or digital transformation. And by being in control here, we do not mean having information scattered in multiple disconnected systems, stored on a drive, or available in a system on the format it was when it was released to production. What we mean is having an environment where the product information is reliable, traceable, and available for collaboration in all phases of the product lifecycle, not only in development, but also along the entire value chain, extended into manufacturing and onto service and aftermarket. In short, really, a digital thread. And by being in control, having access to the data, using that information to make informed decisions, companies are better equipped to manage the risks and adapt to whatever changes that might come. So the question here really is, what role does the electrical design, the ECAD, play in the digital thread today, and what are the possibilities going forward? Well, as Niels touched upon, even though it is a recognized issue, ECAD is still managed separate from the rest of the product in many companies, with manual processes to connect or copy data. This is not limited to companies outsourcing the ECAD design, but also the truth in many companies managing the electrical design themselves. So while the mechanical CAD is a natural part of the digital thread, ECAD is not. So here we see a great potential for companies to take the next step on their digital transformation journey and become in control of the ECAD data as well, not only the mechanical parts of the product. Having the electrical design living its own life, detached from the PLM environment, imposes challenges, especially when operating in this ever-changing world that we're in, which requires more information faster and where the products are increasingly complex. With the information scattered across systems, collaboration between disciplines is difficult. There is a lack of visibility into how changes made within one domain, for instance, ECAD or MCAD, affects the other one, since there's not one place where you can see the complete set of information. Collecting data for regulatory compliance becomes difficult and time-consuming. Same goes for exchanging data downstream towards production and with third parties. And for all we know, the complexity will continue to increase in terms of more components, embedded logic, and software. So managing the connection between ECAD and the rest of the product manually is not sustainable going forward. And this leads us to the obvious question then. Can the electrical design be included in the digital thread? And the answer is yes, of course. You have all the tools already. That allows you to have the ECAD data integrated, not only into the BOM, but also visible in the model across the enterprise and possible to share with production or third parties, and even used in the extended digital thread when the product has left the production facilities. And it can be used in simulations. So what can it look like when ECAD is integrated into the digital thread then? I'm going to share an example with you. So what we see here is a snowmobile in Windchill, where the ECAD information is fully integrated. We see the BOM and we see a visual of the model. You can see a lot of information related to the items in the BOM here. What it is, quantity, what state it's in, if it's released, for instance. And there's also information related to sourcing, if it's a make item or a buy item. We are able to navigate the BOM. We can see the connections between the BOM and the model. You can, from a selection in the BOM, see that part highlighted in the model. And it works the other way around as well. Selecting a part in the model, and you can see where it resides in the BOM. You can zoom in and you can zoom out and twist and turn the model, as well as hide parts. In this example, we want to look at the display unit, since that one includes electronics. So for sake of simplicity, we open this one in a separate tab. And here you can see the BOM, and you can navigate the BOM in the same way as we did for the big snowmobile. And we can click and see the entire ECAD BOM. So the behavior here is the same as for the MCAD. For the ECAD, you can see a lot of information. Here, you can see reference designators being an important thing for electronics. You can see that you have documentation and information available, relevant files. You can also see information related to suppliers with a link to approved vendor lists and approved manufacturing lists. In the same way, you can also view information about, for instance, ROS and REACH, something that we will touch upon later. And having all this information in one place, available for everyone, traceable and reliable, does not only increase the efficiency, but it also improves quality and creates a foundation for good cross-functional collaboration, where you are able to look at the entire BOM, not only the mechanical parts of it. Okay, so far we've looked at the internal collaboration aspects, having all information in one system, but we have collaboration with externals as well. So here we are using MyPDS Search. And the good thing is when having all information in one system, it's easy to search and find information. We searched for the same PCB as we looked at in the previous example and followed the link into Windchill and viewed it there. But you can also in the search portal see the item. You can select if you want to see the complete BOM, what kind of formats you want to see. And for the sake of usability, there's also images available. You can select if you want to see the PDFs. You can open them up to view the information. And you can also select what information you would like to prepare and package for instance, communication with suppliers or even customers. So this is one way of communicating with third parties. This communication can also take place via, for instance, a supplier portal. And when working with the supplier portal, it's also possible for the supplier to upload information that you can, in a later state, then include in the BOM, which can be a valid case if the design is outsourced. Okay, so we've talked about and we looked at what the reality can be like with an integration of ECAD data into PLM and the BOM, examples of what you can see and what you can do. So what values does such an integration bring to a company? First and foremost, having all the product information in one place gives some obvious and immediate values. You have the visibility of the complete product across the enterprise, allowing everyone to look at the same reliable information. This obviously facilitates collaboration, both in virtual teams, across sites, and it makes life easier in production, service, and aftermarket when you can view the same information. This also means that you're able to have the right people working on the right version of the right data. And there will be increased product quality since you have decreased manual activities, you have increased cross-functional collaboration possibilities, and not to forget that we have the quality aspects of having engineering changes covering both ECAD and MCAD in the same system. And this is something that we also will talk about shortly. Also worth noticing, though, is that there are improved capabilities for collaboration with third parties and not only extracting information in an easy way, but also being able to clearly communicate if you have changes and where the changes are. You can manage supplier of the components in a traceable way. What approved suppliers do you have? What approved manufacturers do you have for specific parts? Approved vendor selection, and you can have component cost control, making it easier to manage dual or multi-sourcing. It's also easier to manage product level compliance and verification. Extracting information to be submitted to different authorities and regulatory bodies can be done from one system, but it's also possible to tie the result of a verification to the right instance of the product, providing full traceability. And last but not least, having the electrical design integrated in the digital thread. That's the foundation, the starting point for a digital twin. And by that, I'll hand over to my colleague Mikko.
Hello. It seems that today my camera just, cut himself off, so I cannot show my lovely face to you. Sorry about that. But thank you, Rebecca, for a very nice introduction to the ECAD-MCAD collaboration and why does it matter. So Nils, if you can forward to next slide, please. Summary, now it's coming. So if we take a look at a bit of history view on this one, so what's been out there for, let's say, decades is the founding blocks of the ECAD-MCAD collaboration. At the late 90s, early 1990s, and let's say turning of the millennia, we had already kind of all the basic standards in the place to basically to facilitate the data exchange between the mechanical CAD and the electronics CAD. So if you take a look at the, let's say, Pro ECAD product that kind of emerges at the late 1990s, you could already then bring in the kind of a key components from electrical design, make them visible in mechanical CAD, and starting to collaborating and discussing whether there's interferences between the components or if the bill of material should be in the mechanical CAD or the electronics CAD. So it's quite a long way ago, over 20 years. And over the years, we have refined our technology, make it more and more mature. And today, you really can't tell on the top right image if that is from the mechanical CAD or if that is just a photograph of the actual component. So we are able to really nicely today exchange the product information from one kind of a domain to another, thus enabling kind of a cross-functional team to work. Next slide, please. And if we take a look at how does the actual data exchange happening between the electronics CAD and mechanical CAD domains, we today have text files, which we push back and forth, and they describe the products at the both end of the system. And that has been there for good kind of amount of years. But on the other hand, if we're looking at this like way it's been managed to paste it to the work. So if you just write out the ECAD files to a kind of a disk and then read them in, this leaves a lot of room for improvement when it's come to make sure that you always have the latest version of the data at your hand. So next slide, please. Today, in the PLM system, we can of course introduce new parts. So we have vendor parts, manufacturing parts, we have all the data sheets when you create an items. Click again. And then you have all the authoring applications in the PLM system. So today you have the mechanical CAD in there, and then you have the electronics CAD in there, and you can collaborate them back and forth. And then, of course, since we do have a PLM system, we have all the goodies of the product kind of fun, change management, all kinds of things like collaboration. We have a component of supplier management in the PLM system. And at the last, we also have ability to distribute the data outside of the enterprise and also make sure that our products are compliant. So PLM is really kind of making it possible to collaborate on the kind of one platform between the ECAD and MCAD domains. Please go on. So today, if you look at how does it look like when it comes to ECAD and collaboration, we are still pushing, let's say, text files via PLM back and forth. The systems, we always know that what is the latest version of the files, and it really is kind of a mature technology that works back and forth. Next slide, please. And if we take a small video and take a look how does it look like really? We have the same PCB that Rebecca just showed us. And if you go for different visualization formats of it and open them in the same Creo view system, then something magical starts to happen. So first you open just a mechanical kind of a model where you can see all the components. And then additionally, we will add some more information to here. As you can see, when you say open to Creo view, you can add it to the same session. And thus making all of those three viewables available for you. And in here we have some, drawing for that particular. And here we have a kind of a layout, which you can start controlling. Do we have a logical connections, or do we actually have the routing or the conductors between the components? And do we want to see the printed silics and all that kind of a component information? Just filter based on your needs. And then you can have them side by side, which of course it makes me quite handy to understand what is exactly happening here. So now when you start clicking around, you can enable so-called cross-highlighting. So one working component in somewhere, it's always updating the information on the other windows. So let's see. As you can see, clicking that component, it will highlight on the other window. So it's getting a bit easier today to probe the kind of a product and to find out that what exactly is happening here, or what is the design. And when it comes to collaborating thoughts, if you have a, let's say, geographically distributed design environment where let's say electrical design is the United States, but then the mechanical is at the Europe. Then of course what we want to do sometimes is write notes back and forth, and in order to somehow document the changes or document the requests. Can I move, for example, this one a bit? So what I do is save an annotation set in the model. Write some kind of a comment like, please change this one, or can I change this potentially? Store it, and it will be stored on the windshield on the product information. And of course, you can share that one for your teammate and ask it kindly that would it be possible that you change this one? Please take a look at the link, and when he opens it opens up exactly the same for him as well. So it's enabling really nicely about the collaboration between the things, between the domains. And of course, next slide, please. There's some obvious benefits from this system as well. So PLM really enables you to have a cross-disciplinary design. So one kind of a data location where the master is always stored, and then of course make sure that you can distribute the data for the manufacturing and have the complete product information with you. Next one, please. But if you take a few steps to the future, what it might look like. So far, we've been just having a ping pong between the files in the system. Please, next slide. But how about the future? What will the future hold for you? So let's take this role of that we have a Paula, and she is a PCB designer, so designing those printed circuit boards. Initially, what she does is just collect most key components and just some kind of fun sketch of the rectangular bit black PCB and stores that to system. So this is just the initial. Okay, this is what I might require to make a product. But then Mike, the mechanical engineer, comes to the working place and starts doing his daily job. And one of the things is that what he can do is to connect to the ECAD system alongside the windshield. Take a look at what are the current kind of products that are going on the design, and then just simply connect it directly to ECAD data via server. Then some display manipulation. As you can see, all the components are already available for him, the mechanical engineering kind of a domain. Then what we do next is add, let's say, covers for the product. So in here, some kind of casing, which come from the industrial design team, I believe, and just place it on his mechanical design and start manipulating then the design so that it will fit for the purpose. So first thing to do is, of course, manipulate the board layout so that it actually will fit in the enclosure room. Using just basic modeling operations, we will now make sure that we are able to make the board holes in there, general form, fits, and functions for the board size and shape. And then we just simply drag the models and place them on the PCB board so that mechanically the design is valid without really consulting any of the electronic design, but something that makes sense in the mechanical world. And then at the end of the day, what we do, we will check in our design or push it in for the PCB designer to be amazed of, okay, this is how the mechanical team is seeing the situation, and thus starting the collaboration between the different design teams. And when the Paula, of course, opens up the design, which he made originally, she can see that some of the components has been changed, some of the location has been updated. She can now either accept or refuse the changes, either one by one or let them all come in. And then server is keep taking care of the actual location of the components and everything is used. And now from this point on, she can start her work with the design. Next slide, please. And if we take a look at this one, the server page approach, of course, this is as efficient as it was, with transfer files. But of course, what we can do in here is accept or reject the changes with the previews and everything, and all the history of the iteration history is kept for the later reuse, or let's say if we have to go back for some decisions, why did we make it like that? We have some starting point for that discussion anyway. Next one, please. So what I see is that after this small history introduction is that when we come from the file-based back and forth, kind of sending out and writing in the files which kind of describe the PCB data, we are coming from step by step toward the actual server-based design, where we have all this kind of a design domains on the same PLM, and thus enabling us to really make it nice, complete product description in there. Next one would be Tuomas, I would believe.
All right, hello. My name is Tuomas Eerola. I am the business unit director. My area is CAE and simulation. I work for BDS Vision. I am based in Finland, and my team is all across the Nordics. In the previous presentation, we discussed about the CAD and the collaboration between the different CADs, MCADs and ECADs. In this presentation, I would suggest that let's take a look at design validation. The traditional way is to test. But is testing really the optimal way to do it? I will present how we can do that digitally using simulation methods. And in the end of my presentation, I am also planning to share some tips and tricks on how to really implement the digital design validation. Before we start, I would like to say that digital design validation is not something that is relevant only in a specific product segment. The keyword is electrification. Electrification has brought electronics pretty much everywhere. It's there in your earbuds. It's there in the drones that we see on the news. It's also in the cars that we are driving. They are becoming increasingly complex electronic systems. If we look back some years ago, the electrics of a car were mainly a simple coil for ignition. These days, they have computers, they have wiring harnesses, they are connected everywhere using IoT, and they also need advanced power electronics for charging. This leads us to three terms that we must understand and that we must manage in our product development. They are electromagnetic compatibility, which in principle means that the product works according to the requirements of the designed operating environment. It's electromagnetic interference, which essentially means that the product will not interfere, emit, or receive with other devices. And then there is the third word that I usually like to call simply EMS, because the last word is very difficult for me as a Finishman. That is electromagnetic suspectibility. This means that the product will not malfunction or will not break down when it will be subject to the various kinds of electromagnetic interference. And as you can see, these terms are not separate. They are linked to each other. And that's why it is so important to understand and master them all. You might have heard about the Lithuanian anti-drone rifle that is capable to drop drones from the skies. The rifle causes electromagnetic interference that will exceed the drone's EMS limits, and thus it will take the drone down. So really, EMC, EMI, and EMS they are all connected to each other. In my role in PDS Vision, I have been talking quite a bit to high-tech and electronics companies, and a simple problem that many of the companies have mentioned is slow time to market. But when I have discussed with them more closely, it has become visible that it's actually more specifically unpredictable time to market. So a good example is a company that told me that they have a very experienced PCB designer working. And the designer can usually design phenomenal PCBs and electronics. They just work. But when I spoke to the designer, this person said that obviously he's happy that the company appreciates his skills and experience. But on the other hand, he knows that at some point his luck will end. And when this happens, the product might bounce back from the EMC certification at Intertek or SGS or VTT Labs or similar partner that the company is using. Error correction, redesign, building a new prototype at this point, and submitting that to retest, that will take a lot of time and it will be expensive to the company. And if we look at a mass market product such as the earbuds, having a delay in sales start date can be critical. It can be a real disaster to a company. So the problem that becomes visible in this designer's case is that testing and measurements, they are great. They show that there is a possible problem. But unfortunately, testing and measurements doesn't provide a solution. Locating the problem will rely on the designer's experience and expertise. And this is something that we can now improve using digital design validation. So if we go and offer the PCB designer with simulation tools that connect to the person's ECADs, we can get systems up to standards already before the testing starts. With modern simulation tools, the designer can verify component placement, spot all kinds of impedance variations. I'm sorry, that's a difficult word, variation, and diagnose EMI issues. And this all together, this will help the company save costs and cut down the time to market, and also make the product EMC more predictable. So the testing will actually become just the final validation. Yes, thank you, Niels. So I am not suggesting that simulation would totally replace all the measurements for electromagnetic compatibility. I am suggesting that simulation can streamline both the product development process and the validation phase. And the tips and tricks that I would like to share with you is that please use simulation for digital design validation to prevent EMC issues. And when you have a subsystem design, use simulation to analyze and optimize it. So it really stacks up on each other. And when you have these two under control, then you can even simulate the full integrated system. If you are interested in doing this, I have a great team, and we would be glad to help you navigate this. Niels, let's look at the following slide, and let's see what this looks in numbers. So PDS Vision partners with a company that decided to connect to the growth of electric mobility. They had a long history in business, and they had a really solid experience from power electronics. But this electric mobility, this is a totally new market. And new market means new rules and new requirements that they had to take under control. When they started exploring the new market, they noticed that their speed of prototyping was all too slow, and they discovered problems too late during the product development process. In worst case, that was when the product was in testing at the partner's lab. And altogether, their time to market was simply too slow. And because the market was growing fast, they had to develop their agility. The common denominator in all of the problems was the electromagnetic compatibility. And by implementing design validation and especially the digital design validation into the product development process, they were able to cut down the number of prototypes that they had to do, avoid late failures in product development process, and get a radically faster time to market. And this all provided them huge savings and really a return on investment that was easy for them to justify. To summarize, it was great to help this customer connect to the growth of electric mobility and help them take control of the electromagnetic compatibility things. If you see any similar requirements in your business, please contact me, and it would be really great to discuss with you how we can help you too. I hope you found this interesting, and with these words, I will hand it back over to Niels.
Thank you, Thomas, and thank you, Mikko and Rebecca as well. So we have come up to this part with some questions and answers. So please feel free to fill in the questions tab. We already have a few ones here that we can distribute among the speakers. Perhaps this one is for you, Mikko. You showed the integration with Altium products, but is it possible to do the same type of steps with other ECAD software vendors?
Let's say that Altium seems to be the kind of a forerunner on this one, and its first product that kind of gives you this full server-based collaboration. But I believe that the next other ones are running quite fast on this track as well. But for the rest of the ECAD platforms, what we are currently having is a bit other kind of collaborations, which are a bit like, let's say, previous steps where you still kind of connect the authoring applications to PLM and exchange the files within there, rather than having that full server-based application.
Great, thanks. And perhaps one for you, Rebecca, is if you have any suggestions on how one should start to integrate ECAD in PLM or in the bill of material, if there is like a tip on how to take a first step towards it.
All right, yeah. So first of all, it's looking into obviously what you have, what kind of ECAD you have, and what PLM you have, and also deciding on where in the product and what information that should go over. If you have nothing, and if you have the information scattered across system, a good starting point can be to actually create a placeholder in the BOM to connect the relevant documentation, and then based on that, take the next step. But we are happy to help you in whatever way you need when looking into the integrations.
Right. I guess we can also mention the PDRP then we currently conduct as well, sometimes to evaluate where a customer stands and various pain points that they might have to and set the roadmap together with the customer to be able to start working on this. Perhaps for you, Thomas, I think what would you say is the biggest benefits with digital simulation in general? And you gave a great example here at the end with one of the customers.
I think one of the greatest benefits is really taking control of the product development schedule, because no one wants to have those unexpected late error corrections. With this digital validation, we can shift the testing to happen already during the initial design selection, so that we can have a design that will perform well when we go to the testing and measurements. Then the colleagues, they were talking quite a bit about PLM, and I think as PDS Vision, the great unique benefit that we can offer to you is that we can offer this PLM and digital design validation solution as a full package that works together. Quite often, once you have this first release of the product design, you might want to have a change, and with simulations you can validate the change during the change management and the possible implications. And PLM will be the natural place to store the related simulation models, simulation data and results, so that you will have everything under control at all times.
Right, great, thanks. We also have another question here that is a possibility to integrate software design as well in the future, like linking software updates to changes in the electronical and mechanical design. And I think a lot of information will follow on that, because I know that PTC acquired a new company recently. I think it was before summer, April, May, in that time frame. And they have a product called Codebeamer, which will be integrated into the PLM application suite for application lifecycle management, ALM. And that will definitely interlink with both electronical and mechanical design. So I think I'm not the right person to address this one, but I think there are some information already on PTC's homepage, and if not, I can pull some information together to send to you in regards to that. But we are equally excited for that acquisition that PTC has made, because that has been sort of a missing link in their offering. I think those are the questions we have received so far. You're, of course, more than welcome to, if you come to think of something along the rest of the webinar, please do write them here as well for these first sessions. But apart from that, I guess we will continue, and it's back to Mikko once again.
Hello again.
On the material selection topic.
So let's proceed on the subject then. So no time to lose. Next slide, please. So materials, they are a bit funny in that sense. When you say materials to people, it's always that you get a different answers what it might mean for you. For somebody, it's just a steel grade. For somebody, it's about advanced materials like neodymium magnetics or something like that. So it really heavily depends on who are you talking to. Also, the properties of material that you're interested in is very variable. Some of the people are interested in, let's say, fatigue properties, but another individual might be interested on, let's say, the magnetic properties or electrical properties of the materials. So it's like an interesting question that, okay, materials, but what do you mean by that? And typically with the companies, the material-related activities are kind of goes in either you have a product failure, or you want to just find a second source for some scarce material that there is currently one supplier only, and if anything goes wrong with that one, I need a new one, an alternative material perhaps. Then if you want to develop a new product, then sometimes the existing kind of solutions don't really cut it. You just have to have a bit more advanced approach for it. Then on the other hand, you might have in-house initiatives like cutting costs or making products more green and so forth. Or you might have even the in-house material development where you are trying to develop, let's say rubber compound, let's say composite, or some kind of fun other, let's say, mixture of alloys, which then produce the solution for your product kind of challenge. But for all of these questions, it goes really down to the, okay, what are the materials out there and what are the properties for them? Next one. And on the other hand, in the simulation field, we quite often go and we optimize our constraints, loads and have multiple load sets and boundary conditions and everything. But then you ask, okay, how about material? Yeah, we made that out of steel again. And then somebody shouts out at the back row that said, okay, how about aluminium? And then you're like, okay, maybe, but maybe I just simulate that with the steel. So question is, how would we have it so that actually we can optimize the material selection as well in order to get the optimal product with us? So how do we involve material selection to the product optimization loop is kind of the key question here. Next one. And if you go forward, skip the animations, one more, and one more. So typical approach is really that you have an ongoing issue at your hands, and then you start having a discussions. And since you do have some in-house expertise, some of the people have very used to kind of use just one kind of a material or one kind of a solution. Guy on the back row is shouting aluminium, and everybody is going for aluminium instead of thinking out of the box that how about if we would in this time use, let's say, some plastics or polymers instead to make it product perform a bit better and have a better kind of cost point for it as well. So the question is, how do we make kind of informed decisions based on the kind of challenges what we have? There's a vast array of data available. Next one. We can skip this one, please. And this one as well. It seems that my hiding of the slides doesn't really work. And if you click once more, you will get one extra box in there. Thank you. So what I suggest here is that where we jump is the systematic selection of materials methodology. In the same way, how we define what is the best possible, solution for, let's say, some stress strain, situation like product optimization, mechanical analysis, or let's say electrical thermal analysis. We would do same thing with the materials selection. So define the basic function. What is the geometry and primary loading? Is it thermal, mechanical, or electrical constraints? What exactly do you have to meet? Is it the kind of a maximum insulation value, or is the maximum kind of acoustic damping, or what do you want? And then objectives like what do you have to minimize or maximize? Is it the cost of the product, or is it actually product performance, or minimum bending, or capability of conducting a largest amount of let's say signals through the system? What is the objectives? And then start screening from all the materials, let's say, in the world. Get the top candidates, and then start digging even more deeper and deeper for the exact material definitions. What can you have? Next one. And if we put this in the, let's say, some kind of fun use case, so click few animations forward. We have an electrical connector, which has some requirements like temperature resistance, so it doesn't melt. Second of all, it has to have a low dielectric constant, so it doesn't start alternating the electrical signals too much. On the manufacturing side, it has to be injection molding, so that we can make millions out of them. And then, of course, through HACCP regions, all that what compliance and requirements must be met in order to make it happen. And of course, the objective of all this design is minimize the raw material cost. And if you know by today that it's polyethylamide as a plastic, question is, what is the best possible material for this kind of use case? What kind of performance can I get from it? And do I get any cost kind of benefits for it? So if we go and look at the small video, which I believe comes next, we will see in here at the Ansys Workbench environment, one is having a Granta selector, kind of an application connected to that one. And then you open it up. and start searching for connectors as a general thing, going for materials universe database, and in here you can say that, okay, polyether amides are typically used as in a connectors, electrical connectors kind of a design. So, and then you take a look at the data, you will find out there's price data, there's also mechanical properties in there, there's an impact and fracture properties, thermal properties. And then my video is lagging a bit behind me. Let's say multiple kind of fun properties for the system. Oh, it seems that my video was paused. And you even do have a healthcare and food and all restricted substances index risks and all that. So we have a current kind of a generic polyether amide data, and in here we have some brand names like Ultem. And if you take, let's say, some even deeper data for it, you can get there. But on the other hand, you can say that this is my reference material, which I start to comparing with. And then what we do is say instantly that, okay, I just want to have the possible candidates that are injection moldable, since that is my preferred manufacturing method. And then on the other hand, let's have some additional limits like the glass transition temperature and the dielectric constant. So you put a minimum glass transition temperature of 200 degrees, and then electrical properties you are putting here 3.5 as a maximum value. And then what we do is start searching for the potential candidates. And of course, in here, since the ROHS and REACH are pretty interesting for us, we are also having those as maximum values. And then if you do something which is a pretty kind of fun, nice feature of this Granta selector, you start to plotting things against each other. So what do we do here is have electrical properties of the dielectric constant, which you plot against the price of the per unit volume. And if you look at now, you will find out that there's all potential kind of materials in the world, but in here we have the nice ones, which are the polymers. And in here, what we have is the current reference point for polyether amide, and then some other plastics as well. And as you can see, we have something that like a polycarbonate is having a nicer price point, but also it is still in line when it's come to dielectric constant. And if you then start to comparing some of these plastics together, we can have this stable view of comparing exactly the particular values that you might be interested in, or particular properties that you might be interested in. And when it comes to simulation of the thing, oh, let's see what we have in here. And if you still go in deeper in the data, you will find out that, okay, it's possible to see that what are the possible kind of manufacturers of the things. And then if you want to push out the material data for the simulation, that is also possible in this case. And if we go back to this workbench environment, what we'll have in here is the same polycarbonate, and you will see that we have temperature-dependent properties exported from the Granta selector. So you can go to the next slide without running this again. So as an outcome, what we find out is that instead of polyether amide, we can go to polycarbonate most likely. Just a bit of investigation that if it fulfills all the other kind of requirements for the material. But what we have kind of shown is that if you have analytical approach for selecting materials, it can really pay off when it comes to the material properties, when it comes to product performance things and the price point of your products as well. Can you go to the next slide? Yep. Just run to the end of these things. I think there's multiple animations which I tried to remove, but it seems that all versions are a bit off. So just to summarize somehow the Granta selector for you. So what we have is the encyclopedia of material data in there, which enables you to have an analytical approach for material selection, compare the properties, and finding the best candidates for your products. And also we have capabilities like compliance and restricted substances are supported on the material selection process. Can you go forward? And then again, you have animation, something like 7 or 8 in here. So click them through, please. So if you think about the corporate wise, I'm a bit overshooting my timing here, but nevertheless, so if we are thinking about corporate wise, what kind of questions do we have? Materials information. We have a bit of the similar thing what you have in the general product data management. We have let's say disparate data, we have siloed teams, we have raw material issues in there and regulatory compliance. And possibly the question is, how can we make this thing better in the corporate level? Next one, please. And one of the solutions could be that one is starting using a dedicated material database for all the materials involved. And of course, this will make kind of for the materials database as a single source of truth for all materials related questions, particularly if you have your own in-house material development, or you have to have a specific properties of the data which is not necessarily commonly available for all the people. And for that single source of truth, it will make sense that what we have is nice. Please go on. If we have a nice integrations to kind of reporting systems like a CAD and the CIS systems, and of course the PLM, where we can feed the downstream systems like MES and ERP. So materials data management starts to be also kind of an important thing for the full product kind of definition and the full digital thread, particularly when we have these regulatory compliance things that you have to feed. Met the product materials don't contain anything that they shouldn't. So in order to describe fully that, okay, what kind of substances we use at the manufacturing and during the use of the product, we might have to go and have a separate database for materials data, and from there derive the kind of results and materials models for the finite element analysis. Make sure that we are having a product documentation in the CAD so that it refers to same materials, then define the materials in the, let's say, PLM as well, so that they will exactly know the recipe of exactly component that we are using, and thus we are able to feed even the ERP system for it. Next one. And this is pretty much the same thing. So for the centralized system for the materials data, what are the beneficiaries for this implementation are, of course, materials engineers who help the material selection process or development process, the simulation engineers who will get the proper material data and reusing that one every time, so we know exactly what they used for the simulation. Then, of course, product design can reuse the data and select the properly documented allowable candidates. And then, of course, the regulatory and environmental people can really make sure that everything is okay when it's come to for product launch. And all of these can be connected to the Windchill as a product description. Next. If you put it in a nutshell, what we are showcasing here, first one was Ansys Granta Selector, which enables you as a desktop application level to really harvesting all the materials in the world and getting the post-processed candidates. But on the other hand, the Granta MI is really giving you the accurate materials information for the particular ones that you have ended up with, document that one and make that part of your digital thread. Thank you. And then we have a next one who is...
That would be me. Thank you, Mikko.
You're welcome.
So, apart from CIE, material selection is also a vital part when we look at compliance. And manufacturers worldwide have over the last year faced more and harder regulations. This has made compliance an even more prioritized topic among our customer base. Most of our dialogues are commonly driven towards the R&D team, but we are now also starting to see that members of compliance or quality teams joins the conversation regarding product lifecycle management and the digital thread. And I guess we can agree that these regulations are put in place for the greater good for all of us, but they do make up a lot of challenges for manufacturing companies, and perhaps even more so for the small and medium companies that have not had a dedicated role or strategy for this area from before. Some of these challenges that we see is a knowledge gap and uncertainty on what regulations that apply and that are required to make the product compliant on a certain market. What responsibilities are demanded by us, and how does this different geographical legislations differ in between geographies? Questions like this is causing a lot of confusion and requires quite some time to invest in understanding and staying up to date with the latest. It also becomes harder and harder for many of our customers to only rely on a few suppliers. With the shortage of components that we've been faced with since the pandemic, we need options with alternate suppliers and manufacturers. And as the shortage probably will be prolonged with the current geopolitical climate and energy crisis, and as more and more companies also become global and will require suppliers also in other geographies, the list of suppliers and manufacturers grow quite long and requires some work to maintain. From the preferred suppliers, companies must also work then to collect the required compliance information. Visibility. When we also have all of this compliance information gathered, it's a challenge for the compliance and quality teams to visualize this to the rest of the enterprise. The R&D team is commonly ahead of quality, and the compliance data is commonly not considered that much in the design process. As some of the components do not pass compliance, valuable R&D time is spent to exchange these components in the final design, the result being a delayed time to market. And this also comes with high demands from several parties to be compliant, from the company board and its investors, as well as the consumers and the customers. We understand the importance of this from our customers, but to be honest, this is also quite a new world to us. And that's why we have decided to partner with some people that know this space very well. We have made our due diligence, and Greensoft has made it as a top tier in that evaluation, bringing the highest quality and most accurate data. They support most, if not all, current regulations, and their service cover all types of parts. It could be commercial, electronic, and mechanical parts, could be custom design parts, or production chemicals that will remain within your product as it goes to market. But most importantly, Greensoft is a trusted partner already to many of our current customers, and they have made their evaluations too. Some spent over a year to evaluate different solutions and decided to go with Greensoft in the end. What is important to know, and what really differentiates Greensoft from some of their competitors, is the fact that they have two main units within the company. The first one being their data collection team. This is the reason why they're having this accurate and high quality data. This team consists of a large number of members that actually do the heavy work of lifting the phone and writing emails to various suppliers. They source your custom commercial components on demand and gather all of this required compliance information for each component. All of this data, it ends up in the second branch of the company, the actual compliance database. They have a clouded or on-prem solution that is available and where they store all of this compliance related information in regards to your components. Then when you add your bill of materials to this database, you can receive the product's complete compliance status for various regions. In the European Union, that could be RoHS or SVHC, for instance. In this platform, you can also trigger various assessments and reportings. This could be skip submissions towards ECHA, it could be full material declaration reports, or it could be CE submissions. So Greensoft gives you the documents to demonstrate that your manufactured products meet the applicable substance regulations in the specific region that you want to enter. And as a joint effort with Ross Management, which is a vendor for Greensoft, we are currently in development of a Greensoft data manager integration towards Windchill. So based on dialogues with joint customers that we have put together a MVP product that aims to solve some of the most common challenges that compliance and quality teams are faced and that we've discussed in these dialogues. And I find this quote by one of them quite summarizing and striking. I spend a lot of time informing R&D employees if components are compliant or not. And I want to eliminate that need and spread the information so that it's easy to understand what components that are REACH and RoHS compliant. We must find a way to spread this knowledge internally, since I'm currently the only one with it. So spreading this knowledge internally, making it visible, has been one of the main objectives for us as we built this product. So how we decided to go about this is to prevent the various compliance status rules and the status for each component in the structure pane within Windchill. Our hopes is that this will allow other departments to be able to mitigate risk and make strategic decisions earlier in the R&D process. If required components has not passed compliance, you can decide for an alternative at an earlier stage in your process. Apart from visualizing the compliance data in PLM, our MVP product also addressed the manual steps that are commonly required to sort for compliance information. As we mentioned earlier in the session, some of this information is commonly scattered. It could be electronic components being in a separate system, or some of the information being stored within ERP. However, if we do store the electronic components within Windchill, as well as the required supplier information, we can, with this integration, also create sort of an automated workflow to send information directly from PLM to the sourcing departments for compliance information, resulting in a faster turnaround time to collect and receive compliance data. The manual process sometimes also results in mistakes of sending, for example, duplicates of the same part for sourcing. So with built-in QA steps and functionalities within Windchill, we will help to avoid this. We are currently in the process of evaluating this product with some pilot customers, and will release additional information about this product soon in various forums. Windchill also have a set of tools that can help us when it comes to the visibility of replacement components and suppliers. And starting with SUMA, Windchill Component and Supplier Management, with it, we can, for example, define and manage relationships between supplier parts and internal parts. We can manage supplier profiles and the information in regards to that specific supplier. You can define your preferred component and supplier by a sourcing context. This could be your specific product line, a factory location, depending on various product existing or new products, for instance. Can also be, you can define supply parts preference, for instance, if you have a preferred supplier or an approved one, or someone that you should not use, for instance. So the sourcing statuses, the manufacturing and vendor parts can also be shown within the structure pane, together with this compliance information from our integration. So SUMA is quite a powerful module within Windchill that can tie supplier information closer to our product data, once again making it more visible to the enterprise and aiding keeping track of supplier information as the amount of suppliers grows. A simpler approach is replacement parts. This is built up by substitutes and alternate parts, where substituting a part can replace the part only in a specific product structure, as opposed to an alternate, which can replace a part in every product structure. This functionality would allow us to define what alternates we have for a certain component, what parts can be used to replace that one, and if it's out of stock at a supplier or do not pass compliance, we can see the alternatives that we can use instead. The best way probably is reuse, and to avoid introducing new components, it's of course best to try and locate components that we have already been using. And one helpful tool for that could be PartsLink and part classification, which helps us ensure that parts that are created and perhaps already sourced already are used in its fullest extent. So classification within Windchill allows you to easily and intuitively classify parts with multiple metadata. And with both visual and faceted search, we can quickly determine what components that would suit our design and pick components that are already past sourcing, is approved, and that holds a high quality. Some of the values that we can bring from this is that we can feel probably confident in entering new markets, knowing that we are in control of the various regulations in the region and how they will impact the product. We can differentiate ourselves from competitors with a robust supply chain and provide all required compliance data related to various components. And with more information available about sourcing and compliance in PLM, we can be more flexible and mitigate risk within the R&D process. I hope this short introduction gave you some ideas of how compliance and supplier information can be part of the bill of material and your digital thread, and how you can mitigate risk and make more strategic decisions based on it. So as we now have taken control of our digital house, how can we work with IoT to expand the digital thread and to gather information from products within the field? Carl Fredrik.
Thank you, Niels. Thank you for the introduction and bridging to this presentation as well. So let's jump to the next slide in this one. So what we have done up to now, we have talked a lot about how to keep the single source of truth and to keep the digital thread for the product development within the company. And that is, of course, very valuable, and most companies will gain a lot from doing so. But in fact, what most companies in reality have is a digital thread that ends on the loading bay. When the product is designed and produced, we put the product on the loading bay, some kind of transport takes it away, and all the digital thread and the digital tracks ends there. So we have almost no understanding of what is actually happening with the product when it's used, how much it is used, and in what way it's used. And that is, of course, something that we would like to change, and we would like to support you how to connect your products, and by that, bridging and continuing the digital thread over the complete product lifecycle. So that's the next slide, or the next animation. Thank you, Niels. So what we would like to do when we go to the next slide, we can see how the digital thread continues from the product and from engineering, manufacturing, and further down the supply chain, sales and support, and also down to understand the customer's operation. And of course, that is a number of drivers why we would like to, and we believe that companies would like to go this way, to be able to have a feedback loop to have a design-driven, data-driven design to accelerate the R&D and innovation. Of course, we want to have, there's a reason or a business driver where you have to understand how you can improve the operation and have a more cost-efficient operation all around. And finally, maybe most important, or at least very interesting part of this, is not only to focus on costs, it's also about how to increase revenue. And here a number of new possibilities come into play when you have the possibility to create connected business models. So having a look on the next slide. Thank you. Thank good. We also have to please go back one. Further back. Thank you. And the subline or the box on the middle, on the bottom. So if most of these issues is that something that we would like to go for or push for from the inside of the company, I would say that the expectations on the benefit created by connected products also increase among customers and from customers and as professionals. We know what capabilities comes with connected products, and we would like to see that the products we use in our daily life really take the benefits of what's possible. Very good, thank you. So let's go for the next one then. We dive into the different drivers and what they really mean. So if we start with the accelerated R&D and innovation, so if that is what we would like to achieve, we see that examples of that could be that we make use of the real world data, that we understand how the product is really used, and that we address or that we design our products out of the actual requirements, not only requirements that we have invented in our offices or in our laboratories. We also understand how products are used, which features are used the most and which are not used at all, and can question ourselves, why don't customers use these features? Are they really poor, or are they designed in the wrong way? And of course, we can feed back data to our simulations and understand if we have a valid model and that our simulations are correct. When moving into driving operational efficiency, it's all about having the right data available at the right time, at the right place for people working in the processes. And that can be done, of course, in a number of different ways. We will come into a few of them later on. And also to understand, so it's not only to provide data to our workforce, it's also to understand how the products are used and how they could be optimized in different ways, and the usage of them especially. When it comes to improving our customer satisfaction, it's very much about how our products can increase uptime, using increased or service levels, and also to come further down in data analysis levels that we will come in the next slide. But we have the predictive maintenance that we are trying to reach, and of course also to support sustainability in different ways. How can we extend the lifetime of a product, for instance, and in that way, or not need to replace the product as often as before. And as said, if these are all cost addressing business drivers, We also have the revenue increasing one, how to create new revenue streams. We see a number of customers that is trying to address an increased aftermarket sales, but it's also where we see both our customers that would like to go this way, but also the society in a whole that would like to go for products as a service, and also an outcome-based business model that you actually pay for what you get. You don't pay for a product, you pay for the benefits the product brings. So let's move on. So regardless the reason why we start this project, we see that we have to be able to deliver all these values, and the more complex values of the business we try to achieve, we need to be more specific on the product. We say that we need to crystallize the generic into the specific. And here is where the digital twin comes into play. Next slide, please. As you all know by now, the digital twin is defined as a digital replica of a physical product. And it's also that it's continuously updated with real world operating data. What we mean by continuously is, of course, dependent on the use case itself and the products. For some, it could be weekly or even monthly. For others, it could be about milliseconds. And regardless of the complexity, that was a, and depending on the, please continue, Nils. Next slide, please. So for us, when we design, we've helped customers design the digital twins. We combine what we are able to capture in the PLM system with what we are able to capture in the IoT platform. And then, of course, connect these two platforms to all the surrounding solutions that we have in place or that we support customer adding. And just to answer the question earlier, we say that for the time being, we add the information about software and software versions into our IoT platform. When products are updated, we also see to that information is kept in the IoT platform. But of course, when we see a better solution for that coming via the PLM data instead, we will have that option as well. But regardless, we see this is the complexity of the digital twin. They will increase, and of course, it's a matter of how much of data analysis you would like to do to address your use cases. And on the next slide, we see this very commonly used description of the different levels of data analysis where you would like to have support of your digital twin, where we can start with the easy ones, the lower hanging fruits, the obvious ones in descriptive analysis, just showing what's happening. When we continue the analysis and getting more advanced, we can continue with diagnostics to understand why things are happening. And to some extent, where we all are heading is for predictive what will happen. And here we have the predictive maintenance with everything that comes to that. And where we are coming really far, we will be into the prescriptive maintenance or prescriptive handling of data, what will happen next. And this is something that we are heading for within the context of Industry 4.0 and other contexts. How could we mitigate things that we see, that we predict will happen, and how can we mitigate those? But of course, as soon as the further to the right we get into the data analysis analytical model, as I am right on the next slide, we will increase the complexity of the data analysis, and it also increases the requirement on the physical and digital models fidelity. Next, please. Just to add some examples of what we mean by this before we go into use further more complex use case description and also a reference case. Where as long as we would stick to or satisfy with descriptive analysis, we can add counters and trends and thresholds alarms. And of course, that is a really good start. What I would like to add to this is that you shouldn't forget to track features used in a product. If you have that possibility, if you, for instance, have a software or user interface, to understand what features that a customer is actually using is of great benefit, especially where you try to analyze a new product or a larger fleet of products, where you should emphasize your continued product development. Features are used, seems popular, and feature that is not used, you can question why are they not used? Is it that they are addressing the wrong problem, or is it that they are designed in the wrong way? Anyhow, we continue with the data analysis with pattern recognition and then anomaly detection. There's I would say the step after, just to support the diagnostics. And then we come into the more advanced model-based predictions, where most companies are heading. And here we will be able to rely on machine learning and AI methods, and of course, make use of simulations and CAE. And if we go on the next slide, we see the potential how this could be used when using simulations and connected to IoT data. As Thomas discussed earlier, we design a product using simulation in different ways, whether it's electrical or mechanical simulations. When we think we have a model that we trust, we can, when that is designed using assumed use case data, we can prepare to validate the data in the actual product by calculating where the different kinds of sensors should be placed in the product. And of course, we add all this data into the PLM system and into the digital twin. When we have products in the field, we are able to collect operational data and feedback that into our simulation models. Well, now we have actual use case data, and we understand what wear and tear and loads there actually is on the product. And by that, we can validate our model. With the validated model, we could also predict what will happen with products that is under certain loads or wear or in a certain environment. And by that, we would be able to predict activities or even plan for different maintenance activities. And that would mean that we should place a work order into the workforce management system or the maintenance planning system to be able to address the maintenance activities at the right time. And of course, also order spare parts so they arrive in a timely manner to that work to be done. Let's continue. So one reference case that we have done or within PDS Vision is this German manufacturer of bakery machinery, the Josna Group, where we have connected their bakery machinery using exactly what we have said here, ThingWorx applications and the PLM data. And what we have done here is an asset condition monitoring solution, but it's also a user monitoring solution. So we both are able to capture data from the product itself on its conditions, but it's also a matter of understanding how it's used. So we go to the next slide. We tie this back to the business driver that we started this presentation with. So the main things on this one, from the customer feedback we have got, is that they are mainly pleased with the possibility of increase the performance in their own service organization. That been able to drive operational efficiency. And what they have done is they have improved their response times to problems, but also are able to get the first time fix rate to a much higher degree. So from that point of view, they have reduced their service costs, and they're also able to give the right data and make that available to the right person at the right time. And of course, when it comes to customer satisfaction, who see that the uptime have increased or the availability of the machinery have increased, they are pleased as well. As the OSNA are able to have this to deliver the increased service levels. But maybe the most interesting thing is that the OSNA sees possibilities to find new revenue streams, as they are now can charge a higher or can variate their service offerings and can capture SLAs on different levels depending what the customer is asking for. And as the OSNA is know or secure or control the data streams for the products themselves, they can rely on the data that they have and plan the service and business accordingly. So next, please. So what we do use for all these to create this digital twin is our ThingWorx platform from PTC. It's a purpose-built platform designed especially for industrial IoT, and it includes its own connectivity capabilities. It's scalable, and it's a secure solution keeping data safe. With using this platform, we can come into place in a very rapid way. We know that we are able to set up the first application in a very short time, and we are able to deliver the data in a number of ways, including AR, to the user that needs it. We build applications on top of ThingWorx to adapt to the customer needs, and the ThingWorx can be deployed in both on cloud, on premise, and in hybrids. And of course, there's an ecosystem around it where we and our partners around the world are developing and adding features to ThingWorx more or less all the time. So next slide, please. So just a basic description of ThingWorx as it looks, the main components. So we have connectors to start with, where we have the possibility to connect to most, or if not all, business solutions and business systems, including AR solutions, and of course the products themselves in different ways. We have the domain model part where we create the description of the product and where we model the product. And then we have the business logic component where we build rules on how to behave if different things happen. And of course, we have the UI elements where we easily define user interfaces that could be consumed on all platforms, phones, tablets, web, and AR. Next, please. So today's takeaway from the digital twin part is that we would like to emphasize that you should start your IoT or digital twin project with a business-driven approach. Make sure to start from a why. Why are you doing this? What kind of business value are you trying to capture? Depending on the complexity of the use case or use cases, you have to have the more or less advanced digital twin to crystallize the generic into the specific. And lastly, we would say that ThingWorx is the perfect IoT platform to act as a core in the digital twin. And by that, I hand over to Nils.
Thank you, Carl-Fredrik. And we have made our way through the agenda to the second question and answer section. So if you do have any questions for Carl-Fredrik, myself, or Mikko in regard to materials, or for that matter, on the other subjects that we had earlier, please feel free to type them in the questions tab. Meanwhile, we have received some already for you, Carl-Fredrik. We have collected data from products for quite some time, but don't really know what to do next. Do you have any recommendations?
That's a really good question. We encountered that a number of times among our customers, that they have been able to set a solution in their products where the product itself is able to send data in one way or another. And then they end up with a rather huge database with product data and wonder what to do next. And here I would like to go back to the presentation and say that you should try to understand what are the main frictions in your own operation, or that where you believe that you can support your customer in their operation, where they have frictions or problems that could be handled or addressed using the data you have that you collect from your products. And of course, it could also be that you have a vision on where you would like to take your company and your customer relation, how to get that closer or further. And starting from that business perspective, and then understand how you can make use of the data to support that business perspective. That's the thing. That's the way to go forward, I would say. Here also, we at PDS Vision have a workshop concept where we are able to support customer to identify these business values and business drivers. But start from a why, then go into how, and then end up in technology. All the technology is available. It's just a matter of finding the right way to use it.
Great, full answer on that one. You have received another one. It's you have talked about the backend features. What about the communication devices needed to connect to products?
Oh, that's the other end of the same question in a way. If you understand why you would like to do that stuff, but you don't know how to connect the product itself. This is something that we work together with a lot of partners to address our customers' needs here. I mean, there are so many different ways to connect a product using, and when you are in a small volume, you can use commercially available gateways and sensors. And in the far end, it's about customizing products, sensors, communication devices, and everything. And it's a matter of how you would like to do this and the volume of product you have to connect, and a number of other ways. So that is an area where we can support you, and we have partners in different aspects to bring in the right technologies. So let's have a discussion on what you would like to achieve, and then we can look into technologies to make that happen.
Great, thanks. Let's see if we have anyone else. Mikko, in regards to the materials section here that you just had, when do
Yes.
you typically need material-specific database alongside Windchill?
Well, I would say that when the compliance really matters for your products, and on the other hand, if you happen to have a sensitive or let's say proprietary data for your materials, that's something that you have basically measured by yourself, so that it's very sensitive. And on the other hand, you don't want that to be publicly available, and you want to make sure that everybody is really using the same definition, let's say for the materials model, for the simulation, or the another and the raw kind of a test data. Then let's say that the dedicated materials information system supports those needs a bit better than pure Windchill, but sure, you can start the journey with the pure Windchill as well.
Great, thanks. Let's see, that are all of the questions we have received so far. Can give you another couple of seconds if someone is typing something out. Otherwise, we have reached the end of the agenda with just a short summary here at the end. Me and the team here will travel to Gothenburg and do the same presentation tomorrow live. So if you want to see this again, or if you have any colleagues that you think should attend this, please have them in contact with us. No additional questions, so I'll move on to this short summary. So we have talked about the capabilities and the values of bringing PLM and ECAD together as a part of your digitalization journey. And when doing that, showing and exemplifying how integrating ECAD into the digital thread can help you as a company to become in control of your product information, be able to extract the information needed, collaborate in an efficient and quality assuring way internally and with externals, reduce cost and lead time by using simulations apart from physical prototypes, creating the foundation for the digital twins. And by all of this, being able to make informed decision and manage the next set of challenges that will come. We know that this might be a little bit overwhelming to think about moving from a current state to a state where all of this product related data is stored in this one location. But we believe a great first step is to start to sketch out a strategy for your digital transformation. Once again, communication is key, and by starting to address and discuss internally where the pain points are and where you have possibilities to improve, this sends, for one, a positive message within the organization with a coherent and joint view, but it's also a great way to start your digitalization journey. And a great way to do that is to start to build a roadmap where you define how you would work currently and how you would like to evolve over time and what values those changes will bring. What you see here is just a simple example from a customer project, but one of those bullets could be to include CIE in the simulation phase. It could be how we integrate with ECAD in the bill of material, for instance. So by starting to outline, you at least have a vision and a view forward of how you want to change within the space. We thank you again for taking your time this morning. It was quite a long webinar this time. Apart from the on-site session that we will have tomorrow in Gothenburg, this will also be provided digitally, I assume, in our webinar platform and also on YouTube, I believe. Handing it over to you, Carolina, to perhaps address on that.
Yes, everything will be available on our webinar platform. So it will be both there and on YouTube for you to get access to. So I will also send out this webinar for everybody who has participated, so you can go back and watch some of these highlights and everything.
Great. And as a call to action, please reach out to us if you are interested in compliance or our own application suite. Please reach out to me in regards to Mikko for CAE, ECAD, and PLM, also to Rebecca in regards to the PLM parts. IoT, of course, for Carl Fredrik, and CAE for Thomas Erola. Thank you once again for showing interest and taking your time. We hope to see you soon again.